Hello everyone and welcome back to a new lesson. In this lesson we explore one of the most important steps in atomic science, Bohr's atomic model. We will start with a quick introduction to understand why Bohr proposed a new model. Then we move to Bohr's two key postulates that explain how electrons behave inside the atom. Next, we will determine the radius of the electrons' allowed orbits. After that, we will calculate the speed of the electron in each orbit. We will see how to compute the energy of the electron and how translation between level created spectral lines and wave numbers. Then we extend the model to hydrogen-like ions, atoms with a single electron. We also determine the ionization energy, the energy needed to remove the electron completely. Finally, we discuss the limitation of Bohr's model. And in the end, with a short conclusion to contact everything together. Let's begin. Have you ever wondered why atoms emit light in bright, colorful lines instead of continuous rainbow? The answer lies in one of the most revolutionary models in physics, the Bohr atomic model. Before Bohr, Rutherford had discovered that atoms have a dense, positively charged nucleus and electrons moving around it. But there was a big problem according to classical physics. This orbiting electron should radiate energy, lose speed, and spiral into the nucleus. Yet atoms are stable. Bohr wanted to solve this mystery. In 1913, he proposed a new atomic model, combined classical mechanics with quantum ideas from Max Planck. There are three Bohr's postulates. The first postulate of Bohr is the electron move around the nucleus in fixed circular orbits, each with specific constant energy. These orbits are called stationary states. The second postulate, the angular momentum of the electron is quantized, meaning it can only have specific values. Given by this relation, mvr equals nh upon 2p, where n equals 1, 2, 3, and h is Planck's constant. The third postulate is an electron emits or absorbs energy only when it jumps from one orbit to another. This energy is given by these relations. Delta E equal E level 2 minus energy of level 1 equal h mu. To determining the orbit's radius, the electron is held in its orbit by two opposite forces. The electrostatic attraction between the electron and nucleus and the centrifugal force of each circular motion. Attraction force equal centrifugal force and given by this relation. Solving with Bohr's quantization rule gives us radius or n equal a0 n squared. Here a0 equals 0.529 angstrom, called the Bohr radius, is the radius of the hydrogen atom in its ground state. And to calculate speed of the electron, from Bohr's second postulate, we can also find the electron's speed in each orbit. Vn equal V1 upon n, where V1 equal 2.19 times 10 power 6 meters per second. So the further the electron is from the nucleus, the slower it moves. And to determining energy of the electron is total energy is the sum of its kinetic energy and its potential energy. After a level math, we get energy level equal minus 14.6 upon n square electron volt. This negative value means the electrons is bound to the nucleus. The closer it is, the more tightly it's held. At n equals 1, the atom is in its ground state. At n separate 1, it's in state of excited, and at n equal infinity, the electron is free. The atom is ionized. Spectral line on wave number. Now comes the beautiful parts, spectra. When an electron jumps from a higher orbit, level 2, and 2, to a lower orbit, level 1, and energy is released as light, and given by this relation, where RH is the called the Rydberg constant. Bohr models also works for hydrogen-like ions. That means ions with only one electron such as helium plus and lithium plus 2. And in these atoms are an radius given by this relation and speed given by this relation to get energy level given by these relations and the number of waves given by where increasing Z nuclear charge makes the electron's energy more negative, meaning it's more tightly bound. To determining ionization energy is the energy required to completely remove the electron. EA equal minus En. For hydrogen, its ground state EA equal 13.6 electron volt. They have also for Bohr model some limitations. Despite its success, Bohr's model has some serious limitations. The first, it only works for single electron atoms. It fails for helium, lithium, and larger atoms. Second, it cannot explain spectral line splitting in magnetic or electric fields, known as the Zeeman and strike effects. Third, it does not explain chemically bonding or the wave nature of electrons. Later, quantum mechanics by Schrödinger and Heisenberg fixed this problem, replacing orbits with orbitals. And we finish it by these conclusions. Bohr model was not the final answer, but it was a giant leap forward. It introduced the idea of quantized energy levels, paving the way for modern quantum theory and spectroscopy. So next time you see the bright colors in hydrogen spectrum, remember that's Bohr model in actions. Thanks you for watching this lesson and see you in another lessons. Thank you for watching and don't forget to like, share and subscribe for more science lessons.